herzlich willkommen zu einer neuen Folge des DTS-Podcasts. Mein Name ist Thomas Lampoltshammer und ich bin der Koordinator des DTS-Projekts. DTS steht für Data-Driven Tourism for Sustainability und ist ein Forschungsprojekt gefördert durch die österreichische Forschungsgesellschaft FFG sowie durch das Bundesministerium für Klimaschutz, Umwelt, Energie, Mobilität, Innovation und Technologie. Die heutige Folge unterscheidet sich etwas von den bisherigen Folgen in dem Sinne, dass die Forscher, die wir heute interviewen, englischsprachig sind, weil das DTS-Projekt in seinem Kern zwar ein österreichisches Forschungsprojekt ist, aber die Forschungsprojektsprache an sich Englisch ist. Deswegen haben wir den heutigen Podcast, wie gesagt, auf Englisch aufgenommen. Sollten hierzu Fragen auftauchen, könnt ihr euch jederzeit an uns wenden und ihr findet alle Informationen dazu unter www.project-dts.eu. Und nun viel Spaß beim Zuhören. So today I have two now renowned experts with me in the studio from the University of Technology in Graz, from the research group in Geoinformation, Johannes Scholz and Majic. And maybe you would like to introduce yourself shortly. Johannes, would you like to start?
Hello, I'm Johannes Scholz. I'm associate professor here at the research group Geoinformatics at the Institute of Geodäsie at Technical University in Graz. And yeah, I studied geoinformatics quite a while ago and I'm doing some research on ABM, GeoAI, GeoKnowledge graphs, but also spatial optimization. And I'm super happy to be part of this podcast series.
Thank you, Johannes. Ivan.
So I am Ivan Majic. I'm working here as a project assistant at the postdoc level at the TU Graz. My main task is to work on the DTS project and handle the agent-based simulations. My background is in geodesy and geoinformation. I have done my PhD in geomatics from the University of Melbourne. There I have worked a lot with spatial databases and error detection and machine learning on spatial data. And now I'm working, as I said, on the spatial agent-based modeling and simulation for the DTS project.
Okay, thank you so much. A lot of our listeners will have no clue what are simulations, agent-based simulation, agent-based models. So maybe we can establish a kind of common understanding to this one.
It's nearly everywhere where you have people or animals or plants or anything that could be a geographical phenomenon and things that have kind of a geographical behavior, like people that are moving around, animals that move around and interact with each other or with the environment. So that's classical what a geographical or spatial agent-based model does. So we model reality, we model geographical phenomena, and the interaction between human beings, but in agent-based models, they are virtual human beings or virtual animals. So we replace the real animal, the real human being, with a virtual, let's say, instantiation, or with a virtual version, a digital twin of a human being or an animal. And they interact with each other like similar to a society, similar to like animals in a national forest or anything. And they do also interact with the environment, which is quite cool because then you can see if you do any intervention in the system, what will happen in future. Maybe if you say you would like to kind of see what people do what the society does if you kind of subsidize, let's say, environmental friendly heating systems in buildings. These are things that you could work on. Or if you say in forestry, for example, we promote, let's say, climate resilient tree species, for example, what happens to the environment in total, what happens to like the animals that are living there, what happens to the stability of the forest. So those are all things that you could model with agent-based modeling.
That sounds really interesting because you mentioned also the environment. Did I understand this correctly that it's not only like you mentioned like humans, you mentioned animals, but I assume I can also have something like artificial like cars, for example, or other objects moving that. Does this also count for the environment itself? So is the environment also interactive or is it just like a bounding box?
Yes, well, I would add on to that and say that environment can be interactive. So if you have certain attractions or restaurants or points of interest, these can also change in the simulation. So they can open, they can close, they can become overcrowded or overcapacitated, and they can do some actions on their own in that sense. So we can have moving actions where agents in the simulations change position, but we can also have other kinds of actions that are coming from these interactions and changes in the modeling environment.
Because you mentioned point of interest, so that's a perfect transition over to the next point, which is the use cases that we are going to work on or are working on in our project. I don't know, Johannes or Ivan, which of you would like to start? Could you elaborate a bit on how these kind of simulations now are used, maybe from a broader perspective in the use cases, and then maybe also a bit more talk about how the two use cases are different to each other?
The first use case in our project, or one of the use cases, is to model the movement of tourists in the city of Salzburg, where there are certain points of interest that are often visited, such as the Mozart's Geburtshaus, or the birthplace of Mozart, or the living place, or different museums and castles in the city of Salzburg. What we do then with the agent-based modeling simulation is we try to recreate the reality, or how would people move along the streets of Salzburg in the real world. We try to model this phenomena and this behavior in a computer or in a digital form, so that we can rerun it and recreate it multiple times. In our use case, tourists are visiting certain points of interest or attractions that are in the Salzburg card system. We have 29 of them, and I already mentioned a couple of them. And now we have to also model or mimic how do tourists make decisions of which POI or point of interest they want to visit next in their visiting sequence.
What would be, because you said like decrowding probably in the Salzburg area, right? And keeping tourists or doing regional development planning in the Bruck Fusch use case to, help the region grow in a more sustainable way. If you think now about data that is used in order to be fed into these simulations, right? Can you give us an example of what kind of data you're using for that, and maybe also why some of the data might only be available or work in one of the use cases, right? So if now someone listens to us, how we discuss about this, and will collect the same data for their use case, it might happen that it would not be necessarily useful, right? So there might be some limitations. Maybe you can elaborate a bit on this.
Yes, so the first and the foremost, we have to set some ground rules and the background for the simulation to happen. And this is the data about the space or the geographical representation of the space where the simulation is happening. So for the city of Salzburg, obviously we need to get streets and roads and the road network and the street layout of the city of Salzburg where the agents are moving. And if we move to another location, such as rural location in the Bruck Fusch region, then we need to get another geographical extent there and another set of geographical data as a background. So there, because of the size of the area and the scale of the area is much larger, we are mostly looking not so much into minor streets, but we are looking at the major roads as well. As far as the data that we are using to base our simulation on in the city of Salzburg, it's a smaller use case geographically, and people are walking around the city of Salzburg. So there it would make sense to use data such as recordings of when the agents have or when the tourists have entered certain points of interest and when they have exited and so on. If we have this information, we can look at how many people are in certain streets or the street crowdness. I'm not saying that we have all of this data in the project, but these are the data that we could use in a city setting when we are working mostly with pedestrians. When we move to a rural setting, such as Bruck Fusch region, we can assume that most of the movements or moving modality of the people is done with cars or vehicles, motorized vehicles, because they are moving for many more kilometers, and the points of interest that they are interested in are set wider apart. So there we are looking mostly as to people moving in cars, in vehicles, and where do these people come from? Because often in the summer season, they do not reside in Bruck Fusch, but they come from surrounding places. And they are, as we understand it from the local knowledge and the local people, they drive through the Bruck Fusch and they visit the high Alpine road on the Grossglockner mountain. So right here we are differentiating, collecting the people or the data or sensing the data on a pedestrian level in the city setting of Salzburg, or on the vehicle level in the rural region of Bruck Fusch.
I tried this out personally. So when I start to look up agent-based simulations, or let's say simulations to predict behavior, especially in touristic domains, often the importance of telecommunication providers comes up, like cell phone data. Is this something that you rely on in the project as well? And if yes, what is it that this special data makes it so interesting for spatial applications?
Well said, Thomas, because spatial is always special. And yeah, these data that are originating from, say, mobile phone providers, they are really nice in terms of giving us an impression on how humans behave in cities or even in rural areas. So what you can learn from those data is that you know which mobile phone is located where in the city. So because there are like cells, mobile phone cells for each cell tower, and then like in cities they are pretty small, so you can pretty accurately say where a person was, or where a person was sitting or was moving around at a particular point in time. And these are the data that we look at. So we do not look at a specific person A or B, but we look at the behavior of the group of people in order to learn how they behave. Meaning we say, maybe there is a group of people, for example, families, or there's a group of people, young adults, for example, or people that are very young doing interrail, for example. And all those different groups of people behave in a different way when they are on a touristic adventure. And we would like to model those different groups with the agent-based model accurately. So we look at the data, see how we can, let's say, group them in different age groups, preference groups, and see what their different behavior is, or how the behavior looks like. And then we put this behavior that we did extract from the mobile phone data, we put that as behavior into our agent-based model. And this helps us pretty much to accurately see how people move around, and to create a digital twin of how people and how tourists behave. And with this behavior, we are also able to model interventions, meaning if we have like a mobile phone application that helps people to decide, or to kind of give them a hint where to go next. So we could basically have a little bit of an influence, or see what the mobile phone application could basically help us to provide to overcome over-tourism at particular points in a city or in a town, for example, and to do sustainable tourism in a way. And we can model this in a digital way, but first we need to know how do the people behave. This is where those data come in.
Thanks for the explanation. Now, picking up on this behavior model, like putting the data into the humans, into the objects you're simulating. As we are not alone in the project, but as our project partners as well, we have one partner, the company Datenvorsprung, which deals with artificial intelligence and how to develop from data models that can be used for prediction purposes, for example. So we will have an interview also with them in one of our upcoming podcasts. So please like and subscribe, as they say. But coming back to this point, maybe you can explain a bit how this interaction works now from this artificial intelligence component into the agent-based simulation. Because from what I understand, you do not have to do it with artificial intelligence necessarily. You can do it in other ways as well. So why did we choose to use this direction and maybe not the other one?
Yes, that is correct. So if we think about the agent-based modeling as I mentioned before, the geographical environment where the agents are moving. So this is the environment of the model. We have the agents that are moving and doing some actions in the environment. These are the tourists, for example, in the city of Salzburg, in our first use case. And then we need to have some decision-making mechanism, right? And usually we can use different kinds of behavior models that are available in the agent-based modeling, or we can use some simple loops or decision-making queries in the model, such as if loops, or if some condition is fulfilled, then the agent does this action and so on. What we have done is, because we want to mimic the reality and try to, as accurately as possible, recreate the decision-making of the real tourist in the city of Salzburg, we have used the data that we have available from the Salzburg Tourism Agency, and that is the data of the previous years of the Salzburg card usage by the real tourists. And this data basically recorded when, for each tourist, it recorded a unique ID, so we can differentiate every tourist from each other. It has also recorded for this tourist every time that they have entered a certain point of interest, or a museum or an attraction. And for this entrance, they have recorded the temporal stamp, so basically the date and the time of when the tourist has entered this place. And when you have millions and millions of rows of data like this, then you can do some data analysis on it, and you can actually build models that can themselves learn what happens in this data and learn certain dynamics in the data. And based on this, we have done, even on our side at Graz, we have done some AI modeling and machine learning, and we have built a model that can basically, now that it is learned, it can get an information about a new tourist. We can tell them we have this tourist that belongs to this age group, that is currently at this location, and that has previously visited these 3 points of interest. Where is this tourist most likely going next? To which POI? And then the prediction model that we have trained before on the real data gives us the prediction for this tourist. And we do this for every agent in the simulation. We believe that by doing this with the artificial intelligence, we are going to more accurately capture the behavior of real tourists in the city of Salzburg.
Thank you so much, Ivan, for this explanation. Makes absolutely sense. We were now talking a lot about data, right? When someone thinks about data and how to store it, probably the persons or our listeners that are more towards like technical aspects or technical inclined would say we're talking about databases. However, in our case, we are one step further than that and using something called data spaces. For the listeners that are in the tourism domain, they probably heard of something called the twin transition in tourism. So where you try to establish new sustainable tourism approaches while leveraging the power of technology. So digitalization, digital transformation. And with one of the, I think, a bit more than 20 goals that are in there, data spaces are explicitly mentioned. So they play a huge role. So this is why I think it's important that projects are pushing that. And also we are pushing this aspect. So coming back to this, maybe Johannes, you can elaborate a bit on how these data spaces are used in the project, and maybe also what makes them different than just another database to store data.
Well, thank you for the good question. Because data spaces are, let's say, the way to, let's say, manage data between different organizations in future. So in the past, or even sometimes currently, data were exchanged in a way, so they were just moved from one organization to the other via file transfer protocol or on a USB stick or anything, any medium that you could think of. The problem is always with that, you have hard copy data, which then resides on a database or on a machine or on a computer, but it isn't updated anymore. And you don't get the real-time data are not covered. So you're pretty static in your approach. And the other thing is, legally wise, you always have to sign contracts between the organizations that share the data, or that where the data comes from and where it goes to, right? So the two parties here. And with the data spaces, we are way more flexible because there are so many organizations that collect data. For example, the city of Salzburg collects data. The tourism cooperative in Bruck Fusch collect data. For what reason ever, the Austrian tourism organization, kind of Österreich Werbung, they collect data. There is the Statistics Austria that collect data. So there are numerous organizations that collect data that would be of particular interest for tourist managers. And in order to leverage the potential of those data that are stored in numerous organizations, we say, okay, those organizations can basically provide the data via a data space so that each and every other interested party or organization can make use of the data. And the data space helps us to do this in a legally sound way. So you basically make a contract on the data space platform between the two partners that share the data. And then the party that would like to receive the data gets access to the data, for example, from Österreich Werbung or from Statistics Austria. But the data aren't stored on a central server. No, they are still within the possession of Österreich Werbung or Statistics Austria. So they do not move away, they do not change ownership, or there are no shadow copies or no shady copies or whatever. No, there is a legal way to basically make use of data from other organizations. And this way helps us also to make kind of money from data, kind of, so you can get reimbursed for sharing your data, or you can give them away for free, but still you have the full control of which data you're going to provide to the others, or which data you're going not to provide for other parties. And this is a super nice way to make use of data. You can search for different data that are available that could be of potential help for you to make informed decisions. So data spaces are really the way forward in data sharing, and to do this in a legally sound way, and to kind of, let's say, organize this in a proper way, and not do like do it in a very much chaotic way, like we did it in the past, just with USB sticks and CD-ROMs, if you remember.
So it makes sense, and it's nice to see, because when I understand this correctly, it opens up larger possibilities of cooperation, meaning that a lot of stakeholders can bring the data together, not losing sovereignty over the data, and basically together we are stronger. I assume also, at least from my understanding from AI models, the more data I have, the more complete it is, the better models I can generate out of these data. So overall, everyone participating can then benefit from that. When we take it a bit back a few steps, now we were talking about two specific cases. Let's call it decrowding and regional development. If you see it on a more like higher level, policy making or like large regional development, what would you say overall are the biggest benefits that decision makers have when they use such a combination of AI and agent-based modeling, in particular, what we are using? And maybe also you can mention a bit what potential pitfalls are there when people using these technologies and, you know, not necessarily program them, but act upon the results that they are providing.
Yeah, maybe I can start with this one. So let's start first off with advantages that we might have. So one of the advantages in combining artificial intelligence and agent-based modeling in one single package or in one single, like say, decision making tool or decision making helper in a way, is that you could use pretty complex and pretty large data sets in order to train your model and then come up with pretty accurate digital twins or digital simulations of what might happen when. So you can, in a nutshell, you can gather the whole complexity of such a complex system like tourism in a single model with the help of AI and agent-based modeling. So, and any of those related problems that might occur, like public transport, like commuting within a city. So whatever is there could be potentially tackled with agent-based modeling and AI. So this is one of the big advantages here. And city planners, tourist managers, they could play around with the system and say, oh, if I do this intervention, what might happen there? Or if we stop like this point of interest or this attraction here, what might happen to the other? How does the stream of tourists might be rearranged because of we stop this here or this one closes down? So all that is basically possible. So we are able to simulate like a parallel future, if you want to, with the help of those complex models and see which interactions lead to which outcomes in future. But this is also comes with great, or has to be done with great care. The problem always is here, because you are so much, you rely so much on data, so that you have to be careful on which data to choose in order to train your AI models or where to get your behavior from, what the people have. You have to select carefully in order to overcome bias that might be built in the data. Bias is, let's say, a hidden trend, kind of, that kind of overestimates a specific phenomenon, like a specific group of people originating from a specific country might always visit certain locations in the city of Salzburg. And you have like 80% of all tourists come, for example, from this specific region. So they might be overrepresented in the whole data set. So this might be a problem because you, let's say, overfit the model to a specific, let's say, user group. So this might lead to wrong impressions how tourists in general behave within a city, or how commuters behave within a city, or how do people take public transport or anything like that. So this is kind of an issue here. So you have to be super careful in which data you select for your AI and ABM models. And then you always have to be careful on which data you are going to evaluate your model. So because each model needs to be evaluated in order to see if it's correct, if it's accurate. And this needs to be done with the help of a data set that represents reality or ground truth, as we call it. And selecting this data set is also kind of complex. So this needs to be done pretty properly, and you have to be, let's say, pretty critical about that, on how to do that properly.
Just a couple of examples for your more data-oriented listeners. That in the city of Salzburg, for example, why there are some pitfalls to using machine learning and AI, and what you have to look out for when you are developing data-centric approaches and data-based approaches, is in the city of Salzburg, we have these festoons that can be reached by foot, or that can be reached by a Festungsbahn or some kind of cable car that goes up to the hill. And if we didn't have the data to build these or learn these machine learning models from an AI on, and if we actually had to go with our own set of logical rules for the behavior of agents in the model, then we would probably build some logical constraints into the model decision-making mechanism that says, well, if the agent used the cable car to go up to the hill, to the Festungs, then they are going down with a cable car or by foot in the next step, or the other way around. but logically, a person can never basically exit the Festung by cable car if they haven't entered the Festung by cable car or by foot. And these are some logical sequential constraints that we can notice in the city of Salzburg and in the way that people have to move around. And when we are building the model from data, it may happen that these constraints are broken. So we have to be extra careful to make sure that there is logical consistency in the predictions that our models and our trained algorithms are giving out.
Thank you so much, Johannes and Ivan. So great care in data processing, great care in building the simulation, and also great care of interpreting it and making hopefully the right decision. So to quote a famous person, with great power comes great responsibility. And with that, thank you again, you two, for the nice podcast, because we already reached the end of the episode. It was a pleasure to have you. And for our listeners, stay tight, because after summer, we are back with the next episode, probably around the topic of AI and going deeper there. So stay tuned and enjoy the summer holidays. Take care.